valve and foot switch webinar. Thank you very much for attending. I'm really glad to be able to share some of my knowledge with you folks. And I'd like to just make a small request and inform you about copyright material. This presentation is copyrighted, and essentially what that means for you is that you can use this presentation for teaching people in your own plant or your own personal use. However, it can't be used for any commercial use without permission from myself. Now, commercial use means you can't use it to make your own presentations that you're charging for, or you can't use parts of it for a advertisement or any way that is can be interpreted as a commercial enterprise. Well, after getting the legalities out of the way, let's move right along. First of all, when you look at a buck of a press, um, it's uh, ho- ho- yeah. Pardon me. Since it's just you, Dave, I'm going to take some liberties here. Dave, Chris, did you just do something that would make something show up on my screen?
No, sir.
Okay, back to it.
Looks
All right,
good.
when you
Go
look
go ahead.
Yeah, when you look at the buck of a press, most
Mhm.
of us all we see is a an oblong that we know has steam coming through it, and that's pretty much the limit of our knowledge. However, it's kind of interesting to note the uh, large amount of engineering and design that goes into the manufacture of one of these bucks. I don't really know very much about what's going on inside the buck here. However, I was surprised at all of the different channels and connections and so forth. So I just thought it would be an interesting thing for people to have a look inside the buck and see what's actually there. Now we're going to talk a little bit about buck valves. There's three basic families of buck valves. The first is an air-operated buck valve, which means that there's a cylinder on the valve which activates it to allow the steam to come through. And you'll find unipress and farinapresses have this particular type of a buck valve. The second type is a type of valve where the steam is held inside the valve by pressure on a valve stem, and this pressure is generated by linkages that go through levers that are located connecting the pedal to the buck valve itself, and these linkages will press this valve stem in, hold it in, and when you put your foot on the uh, pedal for steam, it releases the pressure and the valve stem moves away from the disc in here, which we'll get to in the next slide, and allows steam to come through. The third kind is the older Farina type, which has a yoke at the bottom, and this is connected to linkages that also go to a pedal. And when you press the pedal, it pulls this down and away from the seat of the valve. Once again, you'll be seeing that in a minute. And that is the older Farina type. And it's not only Farina, there were several other companies, but most of them aren't around anymore that use this particular configuration. So you got the Unipress type, the Hoffman type, and the Farina type. And Chris, for your own information on your Sankosia equipment, you've got an electric solenoid that is your steam valve.
Yeah, yeah. Okay.
All right, now this is the way the steam valve actually operates. The parts of it is the valve body, and in the valve body is a valve seat. A valve seat is a conical shaped projection that's cast into the valve body itself. And uh, Below that, what we're looking at here is the valve disc. Uh, the disc is contained in a brass holder, and it's made out of Teflon, and it's cylindrical in shape. We'll see a little bit more about that later in the presentation. Holding this disc tightly against the valve seat is a spring. This is I call it the closing spring. And what this spring does, it pushes upwards, forcing this disc against the valve seat, which prevents steam from entering the buck. There's a piston rod that's connected to a piston head down here, and the piston rod uh, has an O-ring that seals the steam from the valve, from the internal valve parts, from getting into the actual valve cylinder. When this piston O-ring goes bad, you'll be getting steam, and you'll see all kinds of weird stuff going on, like steam getting in your compressed air line. Also, you'll be getting steam coming out of the vent sometimes. The vent's on the bottom, and we'll be seeing more of that in a minute. Um, and the way the valve actually operates is you have a cylinder here and a piston. And what happens is when you introduce compressed air, it pushes down on this piston, and that brings this whole assembly downward, compresses the spring, and moves the valve disc away from the valve seat. This is an expanded view, a magnified view, and when the valve is open, this is the path that the steam takes. The steam enters the valve from two ports on the side, and normally it would be stopped right here at the end of the valve seat. But when the valve seat is lifted away, the steam then flows up and into the buck. Now, there's two type of basic buck valve problems. Um, it's either to steam or not to steam, either too much steam or continuous steam, or too little steam or not enough steam. And what we're going to do is we're going to look at the causes for both of these problems. One of the most prevalent problem for lack of steam is the valve actuating cylinder is not obtaining enough air pressure to operate properly. And the most common cause of this is an air leak, and it's generally leaking around the fitting where the air enters the uh, pipe that allows the air to pass into the cylinder. And the easiest way to find it is to activate the steam pedal and listen for the air leak. You'll hear it. Most of the time, you can actually hear it in an operating plant, but sometimes you can't. The background noise would be so high that you can't really hear the air leaking. And what you would do in that case is you take a screwdriver with a broad blade, and you move it around where the tubing enters the push-in fitting, and you'll be listening for any air leaks or any changes. If you When you hear the air leak, you'll hear air leaking, but when you move the screwdriver near it, you'll hear the difference in the pitch of the air leak, and that kind of helps you identify where the air leak's coming from. Kind of like a doctor with a stethoscope sort of thing, except you don't have anything going to your ears. You just you'll hear it. And I found the best way to find air leaks is when the plant is shut down. Um, Now, I just want to caution you because these areas are going to be hot, so keep that in mind. Make sure that you. Oh,
Yeah, keep going, sir. I'll take
oh,
care of
oh,
it.
okay. I thought someone was asking a question. Um, So you want to exert some caution while you're dealing with the press because it's going to be hot. And for those of you who haven't had the experience of getting burned on a on a steam pipe, it's quite something. You cannot move away fast enough to remain unblistered. So you got to be careful. Uh, if you find an air leak at this fitting, what you're going to want to do is to remove the airline and trim it. The way to remove the airline is to push in on the ring here and then push in slightly on the tubing and then pull it back away from the air fitting and that'll allow you to get it out of the fitting in most cases. If for some reason it wants to be stubborn, you can also shoot a little penetrant into the fitting, wait a few minutes, and then try it again. Um, and that's ninety nine chances out of 100 it'll come out of there. In a very rare instance that it won't, then it's a whole other ball of wax and you're going to have to replace the fitting. Now, when you get the airline out, you'll probably notice at this end of it, at the very end, there'll be some deep, deep indentations. And what you want to do is take a razor knife or a razor blade and just trim the hose flush and then replace it. Now, this is the procedure uh, for if you happen to have a situation where you've got the air leak. And once again, that's very common. Okay, and this is once again just the caution about the press being hot. What I would generally do is I would shut off the press about anywhere for 15 or 30 minutes before I start repairing, making any repairs where I'm going to get my body or my hands anywhere near the heated parts of the press. Okay, the next type of problem that you'll have is if the air is leaking uh, past the piston ring, I should say. Or let me back up again, piston O-ring. What'll happen is when you put your foot on a pedal and activate the buck steam valve, air will blow by the piston, and we're going to see in the next slide. We're going to see what that looks like. The piston looks like, um, and it'll bleed out. The air will bleed out at the bottom of the cylinder. There's two kinds of cylinders. You got one from the United Brassworks valve, which is the brass one on the right, and then the original equipment manufacturer valve from Unipress is the one on the left. Pardon me. And here's the vent for the air vent for the United Brass valve, and this is the air vent for the Unipress valve. And uh, the air will be leaking out of it, will be bleeding out of there at a pretty good rate generally if the O-ring has gone bad. When you have a situation where the air is leaking from the O-ring, um, it requires the removal and rebuilding of the piston and replacing the O-ring. And we're going to get into that next. Before we get to that point, though, there's a couple of checks that we want to run. If for some reason you don't have any if for some reason you don't have an air leak either from where the air tubing enters the push-in fitting or any air leaks from where the air vents out of the bottom of the cylinder, it could very well be nothing more than an adjustment. And that's what we're going to be talking about next. Now, when you're adjusting the valve, what we're going to be doing is we're going to be uh, screwing the cylinder, the operating cylinder, in or out of the valve body itself. Now, the operating cylinder is held in place by a jam nut. This jam nut is shown down. It, it's already shown unscrewed. Normally, it would be right up in here. And the idea of the jam nut is to prevent the cylinder body from rotating. And what we actually want to do is rotate that cylinder body. So what you're going to have to do is loosen that jam nut and you spin it down about a half an inch. Now, I'm going to show you in the next slide or two. I don't exactly know the order right now in my head, but we're going to spin it down about a half an inch and we're going to rotate the body and I'll be showing you how to open up that jam nut and spin it down. The next is we're going to, if you've already turned the power off, we're going to turn it back on and press on a foot switch and listen for the a click of the cylinder piston hitting the stop nut. And the cylinder piston, let me go back one couple of slides here. Here's the cylinder piston, here's the stop nut. So what happens is when you activate this air fills the cylinder, pushes the cylinder piston down, and the stop bolt actually is hitting on the bottom of the uh, cylinder, uh, rod, the cylinder rod. I'm sorry, the piston rod. Sorry about that, piston rod. So what you're going to be doing is you listen for that click, and uh, when you hear the click, you rotate the. I'm sorry, I got you rotate the valve about 2 turns, and you open the steam and return valves and allow time for the press to heat up. Now, I didn't mention shutting off the steam and return lines up to this point because up to this point it wasn't required. But um, I'm going to just mention it now. If you happen to close them, you want to open them up. And you'll operate the foot switch on and off, and you adjust the steam flow by screwing a cylinder body in and out of the valve body. Um, you want no steam to flow when the foot switch is off, and steam to flow obviously when you put this foot switch on. When you're satisfied that you're getting the right steam flow, you'll tighten the jam nut to the valve body, and if there was a cover on the valve itself, which all presses have a cover that covers the entire valve. But in a lot of cases, people remove it when servicing it and never put it back. But if there's one on there, you want to put it back. And step three is you loosen the piston jam nut and screw the piston stop bolt to the position about where it shows it here. Not all the way in, but where you have a few threads showing, and then you lock the jam nut down again. Now, if the buck valve is still leaking, then you got to get a little bit into rebuilding the valve, and that's what's coming up next. First, we're going to remove the buck valve from the buck. I'm sorry, we're going to remove the buck valve cylinder from the buck valve body. You want to be sure that the steam and return valves have been shut off at this point. And there's no steam pressure inside the press. You can check that by just activating the head valve and the steam valve and see if you got any steam coming through there, coming through either the head or the buck. Now, if you do, you can close the head and step on the buck and head valve. I'm sorry, buck and vacuum valve simultaneously, and while you're also pressing down on the head valve handle, and that'll bleed any steam that's inside the press um, off through the valves. Next, we're going to be removing, like I mentioned a little earlier, we're going to be removing the valve, uh, valve cylinder from the valve body. And what we're going to do is we're going to shut off the steam and return valves, bleed off the steam like we just mentioned, and then turn off the power. Next, we remove the cover from the buck valve and spray the area with penetrant. You've already gotten to this point, but what we're doing is using penetrant like liquid wrench. You could use WD-40, but liquid wrench is preferable. WD-40 is more of a lubricant than it is a penetrant. And what we want to do is spray this area pretty liberally with penetrant and let it sit for about 15 minutes. Now, it's pretty important that before you spray this with penetrant, you let the press cool down maybe at least 15 minutes. And if you don't, what you're going to find is that you're going to be just the penetrant's going to hit the hot parts of the press and it's just going to flash off. So you want to avoid that if possible. Next, we're going to remove the air supply nipple from the street L that allows the air to pass into the cylinder. And what I normally use for that is just to break it loose with a needle nose vice grip. Once you get one or two turns on it, you can do it with your fingers. Generally, it's a small, I believe it's a 1/8 inch uh, fittings and nipple. And then you can unscrew the street L from the valve cylinder. Next, we're going to be opening up the jam nut and screwing it away from the valve body. And I think I mentioned to you that that this is the procedure that we're using was required a few slides back to make the adjustment. However, uh, I've got the slides to show you how to do it here. So the first thing you want to do is you put a 1 inch open end wrench over the jam nut. Then you use a 1.5 inch wrench to hold the valve body. The 1.5 inch wrench is what we would call a counter wrench. That's designed to prevent the valve body from unscrewing when you apply torque to the lower wrench that's on the valve cylinder. So you break that loose, and then you'll use a small pipe wrench to unscrew it from the valve body. Now, what you want to pay attention to is that when you're using a pipe wrench on a cylinder, and most of the time that's not recommended at all, but unfortunately, there's no other way that is easily accomplished um, to grasp the cylinder itself. And you want, when you're doing that with the pipe wrench, you want to make sure that you're not putting the pipe wrench anywhere in this area. The ends of the cylinder are reinforced and can handle the compression from the pipe wrench, whereas in the center, it'll tend to distort or collapse a little bit. And once that happens, that cylinder is history. Now, what we're going to do is we're going to take a look at the cylinder bodies. Once we have the cylinder out of the out of the I'm, I'm, once we have the cylinder out of the valve body, we can have a look at it, and a lot of times it'll give you some information about the condition and what's happening inside of your steam system. Now, on the left here, you can see a lot of scale deposits on the valve, the internal parts of the valve. And what this indicates is that you've got some surging in your boiler. What surging means is that the boiler is pushing liquid up into your headers, and that's not a good condition. What that eventually will lead to is clogging your steam traps, and also I've seen occasions where it builds up a deposit on the heads of the presses, like when you uh, press on a steam pedal on a puff iron or on a press, the steam will blow out of there with this scale in it, and it'll build up a layer on the surface of the machine part, like like the head of a puff iron or a press. And sometimes it gets pretty thick. I've actually had to use a wire brush to grind off about a 1/8 inch deposit on puff irons that in a plant that was experiencing a problem like I'm explaining, the surging of the boiler. Um, Another situation would be you would see the possibility of rust inside the steam chamber of the press itself, inside the buck, and it'll sh- show itself as a reddish deposit on the parts. You have to be a little bit careful because also there are some boiler compounds that will coat the inside of the pipes and such, as well as the valves, with a red deposit. And the way you would determine which one it is you could take a white piece of paper and scrape off some of the debris, some of the deposit, and put a magnet near it. And if the magnet attracts the debris, it's rust, and if it doesn't, it's boiler compound. All right, now we're going to have a look at the valve cylinder itself. And the part that we're primarily interested in is the disc holder. Um, when you remove the operating cylinder from the uh, valve itself, you want to get a inspection mirror and a flashlight and have a look up into the bottom of the valve body. And as you're looking up, you're going to see this shape, and inside there's another central ring. It's got four ports in it, and in the center is the valve seat itself. Pardon me. The valve seat is a conical shaped projection, uh, and what we're looking for is to see if there's any dings or cuts in the valve seat. If you find that there's some valves, if there's dings or cuts in there, that means that you're going to need to replace the valve. So at this point, uh, you wouldn't be going any further than buying a new valve and installing it. However, if the valve seat in uh, is fine, then we move on to our next um, inspection, and that inspection is of the disc holder. Now, this is the side view of the disc holder. The top view, what we're looking for is any depressions in the um, Teflon disc that's in the disc holder. If you take a look on the side view, you'll see a Teflon disc. And the Teflon disc is what actually seals the steam. So in the course of the aging of the press, the valve seat will push further and further down into that Teflon. And once it reaches a certain point, the Teflon in the center will begin to form like a cone. And when this happens, it starts to lose its sealing capability. So it doesn't seal the steam as well. And what we need to do at that point is to replace it. And that's what's coming up next. Replacing the Teflon disc holder. Before you get started doing any repairs on not only the press but any other machine that you got in your plant, you want to have the spare parts available to replace if you run into a point where you need to actually replace them. And here's what you're going to need for the replacement and servicing of uh, uh, of the operating cylinder. You're going to need a disc holder, a brand new disc holder, a closing spring, and a roll pin. Now, the O-rings are used for a different type of repair, but I've included them in this grouping. In order to get the pin out of the Teflon disc holder, you're going to need a roll pin punch. Let me take a moment and explain to you the difference between a roll pin punch and a regular, what they would call drift pin punch. A roll pin punch at the very end, it's got a little conical projection on it, and what that does, it fits inside the roll pin when you're trying to drive it out, which is the next slide. This is a kit. I'm not going to get into this right now. We're going to move through this. This is uh, it, Dave. I would talk to George or you about buying a kit if you had a question about the uh, a question about replacing the valve parts. But you've only got one press left. That's it. Well, no, actually, yeah, the presses that you have are not applicable to this, so it really doesn't make too much difference. There's
Yeah,
only one
correct.
press you got that's applicable to it. However, on that press, if you ever need to change it, let's go through the whole procedure here. Um, the first thing we want to do is you want to spray the area here with penetrant, and then you're going to place the cylinder on a V block on one side with a stand on the other. The stand is to keep it level, so when you're driving a pin, it's not on an angle, so you can just drive the pin directly down. Then we're going to take the pin punch and we're going to center it in a roll pin and drive it out of the disc holder. Then we take a new roll pin and tap it through the disc holder till it just projects a little tiny bit. And that little projection is what we're going to be using to locate a hole in the piston rod. And here we're looking at the disc holder, the piston rod, and the spring. You'll notice the hole in the piston rod. If you are if you don't have that little projection going through, it's really hard to line up this hole with this uh, with this hole in the piston rod. So what you're going to need to do is when you have that little projection coming through, ordinarily you'd see the pin here, but I didn't show it that way. It would be sticking up, and you could feel that hole. And once you feel the hole, you can just tap it through, and it'll go cleanly through. If you got to fish around it, you'll probably go through a couple of roll pins before you get it right. This way, it's pretty much a slam dunk because you can definitely feel that roll pin entering that hole, and then you just tap it in. Now the next problem that we're going to be dealing with, and Dave, this is good for any time you're working with O-rings and pistons. It's not only we're talking about this particular machine, but or this particular valve. What you want to do is this is the kind of procedure you would use. You-
I got her. Keep it going. Just a little background noise, sir. Keep going.
yeah, okay. I'm trying to locate something here. Um, all right. Once again, we're going to be dealing with holding the cylinder uh, with the pipe wrench. And once again, I caution you on how to do it so you don't collapse the cylinder. We're going to break the end cap loose from the cylinder and unscrew it. And this is the end cap. That's what it looks like. Then we're going to take some penetrant and we're going to spray the piston rod and put a blast inside the cylinder. And also, my fingers are covering the port. You'd also put some in the port. And then use a drift pin punch or a flathead screwdriver or a Phillips head screwdriver and push the piston rod until the piston comes out of the cylinder. Then we would take something like a pick and remove the O-ring and clean up the groove that the O-ring was sitting in with like penetrant or some kind of a solvent. You're going to have the penetrant handy, and it works good for this. So you blow some penetrant in there, and then you'll uh, you know take a rag and clean out any existing lubricant and grease and debris. Next, you're going to fill the piston groove with a coating of lubricant. What I use, and this is good for all, like I said, this is good for all O-rings, Dave. Some kind of a silicone lubricant, and that's especially designed for O-rings. It's got the advantage of it's pretty, it retains, it's pretty retaining. In other words, it doesn't wash out of the cylinder. It lasts a long time, and it's extremely resistant to heat. It's good for about 400 degrees, which you're never going to see in a dry cleaning plant, but it'll last a long time. The hard part is replacing the O-ring at the neck of the cylinder, and the reason I say it's difficult, it's not all that difficult to remove, but it is difficult to replace. So what you'll do is you'll use the pick, and you can get behind the O-ring and move the pick around, and you'll be able to grab it and pull it up a little bit, and then grab it with your fingers or a needle nose pliers and take it out of there. Um, However, when you go to put it back, first you want to clean up the groove that it sits in and fill the groove with some lubricant. Then you'll put the O-ring back in. And the way to put it in is you fold it and get one corner in, and then you kind of keep working it around until you get enough in, and then you can just press down on it with the end of the cylinder that I'm sorry, the end of the piston rod going the opposite way and push it in there, and it'll snap right in. Now, the piston rod itself, before you replace the piston rod, you want to make sure that it's smooth and especially at the end, it doesn't have any burrs or any raised portions of it. It's not flattened in any way. Because if it is, it's going to cut the ring, the O-ring, when you go to push it through. It's going to be really hard to push through. Even without any burrs or raised portions, you still have to kind of work it around a little bit to get it through the center of the O-ring. Um, Make sure that you have lubricant, like I mentioned in the last slide, in the groove, and make sure that you have lubricant on the piston rod also. To reinstall the cylinder, what you would do is, first of all, you're going to Teflon up the end cap, and you're going to Teflon up the neck of the cylinder, and you're going to screw this in and tighten it down with a wrench, just like I showed you before, and you're going to insert it up into the valve and screw it in. Now, one of the things to keep in mind is that on valves of this type, the United Brass type, it's the spring has got a little bit of extra space in here, so it's not a problem to push it into the push the neck into the valve body, which is still in the press, um, and start screwing it in. It doesn't require much upward force. However, with the uh, unipress type valve that has the cylinder on it, the spring is a lot more compressed, so it's hard to push it up in to get into the point where you can catch a thread. And the best way to do this is to hook up the airline to it and step on the pedal And when you do that, the valve will contract. In other words, this will pull back and shorten the length, and then you can get the screw thread started. Next is the head valve section. These are I'm trying to yeah your head valve, Dave, is also operated. I'm trying to yeah this isn't applicable to the Sankoshas in any way. Um, the head valve has a screw plug in it, and this is the actual operational part that keeps the steam from leaking through the head valve. Many cases, I would walk in on a service call, and every press in the plant would be leaking steam from the head valve, and most of the time it's just this quick little fix, and you're good to go again. So this is what this next series of slides is going to be about. Before we get started taking anything apart, we want to make sure we've got what we need. Here's the tools and the parts that are required. And pardon me. Um, before we change anything, we want to make sure that it's required. So what you can do is you can just screw in a couple of turns on this plug and see if it stops your steam leak. What you're doing when you do that is you're applying a downward force, you're applying an upward force on the handle that tightens up the I shouldn't say tightens up, which increases the pressure on the valve stem, which keeps the steam from I'm sorry, keeps the steam from passing the valve disc. The setup in this particular valve is very similar to the setup in the buck valve, in as much as you've got the same valve disc and it's pressing down on the valve seat the same way it is in a buck valve. The only difference is instead of being air operated, this one has a mechanical type linkage where you got the handle and the spring pushing up. This end of the handle is pushing down, applying force against the valve disc, uh, pushing it against the valve seat in order to stop the flow of steam. So if you if the adjustment doesn't work, we're going to move on to the next step. You're going to shut off the steam and return like we said before, and then you'll close and lock the head. Once again, when I say shut off the steam and return, I mean leave it off for about 15 minutes and bleed the press down, just like the procedure that we covered initially for the buck valve. Now we're going to shut off the steam and return and close and lock the head. And then we're going to press down on a steam valve while we're performing step two. Now, I usually for safety's sake, put a couple of hangers over the small end of the buck to prevent it from completely opening. Uh, because when you close and lock the head, a little air bleeds out over the course of time, and after a few minutes, it may very well open up. And you want to make sure that you've got something to prevent it from opening all the way. If you got the valve apart, you don't want the parts flying everywhere. So that's the reason for this. Next, we're going to unscrew the plug from the valve handle, and that exposes the spring. Uh, there's a there's some um, valve handles that'll have a set screw here, a Allen set screw that keeps this from turning. So you want to make sure if you have a valve handle that's got a set screw in it, that you loosen up or remove the set screw before you try turning the brass plug out. Because if you don't, you can strip the groove in the top of the plug, and that just makes life a lot harder. It doesn't mean you can't get it back in, but it just makes life harder. When you got the plug out, what you want to do is you want to remove the spring. And the best way I found to do that is just grab it with a needle nose pliers and lift it out of there. Um, in many cases, this is what the spring is going to look like when you get it out. Almost all the time that you see steam leaking from your head valve, it's because of a broken or um, spring that's kind of lost its tension. So you got the spring out. Then we're going to replace the spring with a new one, and then you'll lift up on a handle. And what you're doing when you lift up on a handle is you're giving more space uh, for the um, screw to screw in. Uh, in other words, you need to put downward pressure on the plug. Let me back up here. You need to put downward pressure on a plug to screw it in. And when you lift up the handle, it reduces the amount of downward pressure you have to put on the plug. If the handle's laying flush against the head, um, you won't be able to get that plug in. So you're going to need to lift up on the handle and then push down on the screwdriver to get it started. Okay, that's pretty much it for the head valve. Of course, after you get it all put together, you're going to turn the steam back on and adjust the plug. You can screw it in if you have a steam leak. You want it screwed in the minimal amount to stop the steam, and then you just give it another turn, and that way it'll maintain that adjustment, and you're not unduly fatiguing that spring. On some presses, uh, they have a cylinder that works that head valve in automatic. And sometimes there's a pretty fine line between stopping the steam from leaking and having that cylinder have enough oomph to open a valve when the automatic uh, uh, head steam comes on. So you want to make sure before you leave that you're operating okay in the manual mode, in the automatic mode rather. Okay, so far, Dave, you got any questions? Oh, Dave's got his.
Look, I'm muted, but I'm good. Everything is
Oh,
good, Bruce.
okay, all right, all right. Now we're talking about rebuilding the foot switch. These foot switches go bad pretty frequently. And when we want to rebuild it, what we do is we want to remove the lid and get to the switch innards. And the way to do that is you got hinge screws on both sides of the switch. And what we'll be doing is unscrewing these hinge screws. You want to be careful not to lose them because it's not a normal kind of screw. It's a special screw. So if you happen to lose one, you're going to have trouble replacing it. Once we get the lid off, the switch has got a plastic cover on it, and we're going to want to take that off to get to the switch body itself. And the way that we do that is we've got a tab that kind of locks it in place. You just push back gently on this plastic tab. In the older switches, the plastic kind of degrades after a while. So if you give it a good push, you're likely to snap it off. Now that's not a really big deal, but because the switch cover, this plastic cover, has a couple of pins that locate it anyhow. But if you're not, it's a good idea not to break it if you don't have to. All right, so we remove the switch cover and we remove the spring. The spring sits in that little cavity there. It locates it and keeps it from falling out of place when you're reassembling the switch. Now we're going to take the spade lugs off of the switch. You're going to pull the connectors off of the switch. Note where they went because you want to put them back in the right position. Uh, at this point, we're not going to before you unscrew the ground wire. What we want to do is touch the two spade lugs together and with the power on and see if you hear the switch. I'm sorry, if you hear the valve actuate. if you hear the steam valve actuate. And if you hear it, the problem is not in the switch, it's in the wire, which I'll explain to you in a minute when we get to the next slide. Incidentally, I'm trying to remember. You probably. I'm trying to remember if you have this family of switch in your plants. I can't really remember, Dave. Okay, what we're going to do next is we're going to unscrew the retaining screws that are holding the strain relief clamp in place. So we're going to unscrew these, and then we're going to open up the um, uh, the strain relief clamp and unscrew the. Oh, let me back up a second. If you touch the wires together and the switch actuated, and I'm sorry, the valve actuated, what that's telling you is that it's the switch that's the problem. So let me go back one slide here. If you touch these two um, terminal connectors together, and this and it actuates the valve, that's telling you that it's the switch. If it doesn't activate the valve, that's telling you that it's the wire. And what happens is with this strain relief, after a period of time, it'll actually, in some cases, will actually cut through one of the wires. And if that's the case, you're going to have to strip the wire back and put new connectors on it in order to um, rebuild a switch. Now, it's not a hard job, and there's generally enough uh, length of wire where that's not going to be a problem to strip it back an inch or two. And uh, it's kind of like a fairly common problem. You'll see that probably about maybe 20% of the time that you have to deal with a switch. Next, what we're going to do is we're going to reconnect everything. And you want to make sure that the terminals go back on the lugs of the switch that they came off of. And of course, you reconnect your ground wire. Um, and then we're going to uh, replace tighten down the strain relief and put spring in place. And I want to bring your attention to the uh, the screw. I mentioned earlier that the screw, it was important not to lose it. And here's the reason. As you're looking at the screw, the end of it, let me go to the next slide. The end of it is rounded. And this end here actually acts as the hinge pin for the lid. And if when I say the hinge pin, it means this area is designed to pass through the body of the valve. It screws into the lid and this part passes through the body of the valve and allows the lid to move up and down easily. If you screwed it in all the way, what would happen would be the switch would be kind of useless. It would stick in one position. When you closed it, it would stick shut, and then when you pried it open again, it would stick open. And it's important to replace the lock washer also because the lock washer acts as a spacer to keep these threads from entering the switch body. I want to just go back a slide. Okay, here's the switch body. You notice these holes here? Um, those holes are where the end of the screw goes through. If it's screwed in too far and you get the threads into this area, it doesn't allow the lid to pivot properly. And when you go to put the switch back together, what you'll do is you get the wires reinstalled, and then you visually line up the hole and you put the screw in. One of the good thing to remember is if I don't know if you know how to magnetize a a screwdriver, but you just take the tool, you take the shaft of the screwdriver or Phillips head screwdriver or whatever you want to magnetize, and you just slide it in one direction across a strong magnet, and that'll magnetize it. Um, and the screw will, obviously stick to the screwdriver by itself. They actually make tools to do it too, but the tool isn't really necessary. All you need is the magnet, and that's it. That's all the news is fit to print for this one.
Awesome. Thank you,
Hey,
Bruce.
All right, Dave. You want to turn your video on so I can see your ugly face and recognize you when I see you?
I mean, maybe it wasn't working before. I thought you guys had gotten me off of it. Can you
No,
see
no,
anything now?
no. The video's off right now, and
there's something wrong with your feed. The video's turned on in Zoom, but there's something with your camera.
Oh, okay, okay, that's what it is.
Oh,
I thought you had purposely shut it off.
I wish
Um,
it was like that.
all right. Well, thanks so much, Dave. I really appreciate you, attending. Unfortunately for me, you're the you're the only attendee here. So,
Everybody gets their start somewhere, sir.
yeah, I hear you. Send my regards to the crew. How's Gabor doing? I haven't seen or heard
So we
from him in a
actually
while.
we need to